Hello everybody and welcome back to another episode of Edmund's Maths. Now, we've been looking at the incomplete beta function recently and I now want to define its inverse. So we're going to be looking at the inverse incomplete beta function. But how are we going to find out what this is? How are we going to write this? Well, any inverse function will generally satisfy the rule that if you take the function of the inverse, then it will spit out x itself. So we'll define the inverse incomplete beta function that way. Now, if we take our incomplete beta function, therefore, and shove in the inverse incomplete beta function, then by definition of the inverse incomplete beta function, it will be equal to x. Okay, and I'm going to call this equation 1, and I'm going to call this one equation 2. So equation 1 is the defining formula for our incomplete beta function, and equation 2 is our defining formula for our inverse incomplete beta function. And now we want to actually find out a formula for what this is. So let's go ahead and stick this into there. So therefore, beta nm of beta nm inverse of x will, by equation 1, be equal to the integral from t equals 0 to the inverse beta of nm of x. So this inverse incomplete beta function is now in the limit of the integral, and that will be dt of t to the n minus 1, 1 minus t to the m minus 1. Okay, and by equation 2, this thing is going to be equal to x. Okay, so we've now got our defining formula for the inverse incomplete beta function. Okay, and I'm going to call this equation 3. Now, we also want to find the derivative of the inverse incomplete beta function. So we want to find out what's ddx of this thing. When you define a new function, you always want to find what the derivative of it is. So let's go ahead and do it. Now, you might be thinking, well, how are we going to do that? I mean, we haven't got a formula like beta to the minus 1x equals something. So how are we going to do this? Well, we can use our best friend, implicit differentiation. So let's go ahead and differentiate both sides of equation 3. Okay, so that implies that, well, first of all, we need to differentiate this side. And this looks kind of messy, this looks kind of hard, but we can remember our Leibniz formula that we looked at in the first video, and therefore the differential of this will be the differential of the limit. So we'll get dx of this limit, which is so nicely the inverse incomplete beta function, multiplied by, now you can look at Leibniz's rule from the first video. I'm not going to state it again here. I'm just going to follow it. So here, this is now going to be multiplied by the integrand, where the dummy variable is replaced by the limit itself. So then I'll therefore get beta nm inverse of x to the power of n minus 1 multiplied by 1 minus the inverse incomplete beta function, nm to the power of m minus 1. And well, so far we've just differentiated this side of the formula. When you differentiate a whole formula, then effectively you are differentiating both sides. We've differentiated this side, so therefore that's going to be equal to the differential of this side. And very nicely, that's x, so the differential of that side is just 1. Okay, so, look, we've got our differential of the inverse incomplete beta function now. So all we have to do is just rearrange this to get this guy on its own, or girl. So all we have to do is just divide both sides by this beast here. Okay, so the easiest way to do that is just by looking at these powers and knowing that 1 over this is just going to be the minus of these powers. So therefore, the derivative of the inverse incomplete beta function is going to be given by the inverse incomplete beta function to the power of 1 minus n times by 1 minus the inverse incomplete beta function to the power of 1 minus n. Okay. Thank you for watching.